Hello everyone.
Hello, good evening, everyone.
Good evening, ma'am.
Good evening.
Okay,
Good evening, ma'am.
good evening. Fine. So we should wait for some 2 minutes. So, so today we are going to discuss the topics of week 2. Fine. Okay. So I hope you guys have got time to go through the content of week 2. We will discuss it. It's nothing but the representation and how the category variable we do some analysis on it. Please mute your mic if you are not speaking anything. Just tell me whether the screen is visible or not.
Hello.
It is not visible, ma'am.
Okay, just a minute.
Ma'am, currently it is not visible.
Fine. Now is it okay?
Yes, ma'am.
Yeah,
Yes,
it is.
ma'am.
Okay. So today we are going to start with the week 2. Was there any doubt with week 1? Like there was one question uh, regarding that book rating, right? Is there anyone who has attended last classes of doubt session and solve with us session? Fine. See, we were discussing the question of book rating. Let's say someone has read the book, and now we are collecting the data about the ratings given by people to the book, right? So the question was whether the rating can be ratio scale of measurement. So the answer is wrong. Answer is no, because see, book rating uh, can be either ordinal or interval. So I will just give you a reference. I will just give you a context. You just tell me whether it should be a ordinal or interval. Then we will move to why it can't be ratio scale of measurement, ordinal and interval. Fine. See, if someone is giving rating as, let's say, good, let's say satisfactory, good, and what we say, excellent. Fine. They are giving rating according to this three, and the rating is like, let's say, 1 for satisfactory. They are giving 1 star, 2 star, and 3 star. Fine. And similarly, then what kind of variable it is, like what kind of measurement scale is used here when you have
Ordinal.
a right, even though there is no like there is some interval between the same interval difference between 1 and 2 and 2 and 3, but still it's not interval. Why?
Because, ma'am, it's categorical data.
It's categorical data, yes, and the difference between these things, good, excellent, we can't measure the difference, right? And yeah, it's categorical, and there is some order, so it's ordinal. Similarly, if someone says, okay, you have to give the rating uh, in 1 to 5, then
And then it
just,
will be interval.
yeah, then it will be interval, right? But whenever you are, even though, let's say, you are saying someone, you can give the rating from 0 to 5, still it can't be a ratio scale. Why? Because if someone is giving 0 to any book, like 0 is not denoting anything uh, when it comes to rating. And even we can't have multiplication or division kind of things. We can't compare it like, okay, this book is twice good as the another book. So that's why the ratings, when it comes to book rating or any rating kind of things, it cannot have a ratio scale of measurement. Fine. Okay. So now in week two, what do you had? Yes.
I mean, paragraph is a ordinal or a not?
Sorry, you are not audible.
If we have a data of paragraph, it will be ordinal or nominal.
You are not like your voice is not clear. Please, can you please put your question on chat? So till now, what we had uh, given some data. We used to uh, distinguish between them. Like we used to check whether the data is categorical or numerical. Fine. And then we used to find what kind of measurement scale it is going to use, right? Fine. Categorical. And another one was numerical. Categorical, if the data is categorical, then we used to check whether the data is nominal or have some order there. So if even though data is in numerical form, still it can be a nominal. And if the data has some order like this rating, satisfactory, good, excellent, then we say even though the data is categorical, it has some order, so it is ordinal. And then if the data is numerical, then we used to check whether it's interval kind of scale of measurement or ratio scale of measurement. Interval and ratio. Whenever it's interval scale of measurement, the difference between uh, the two values will be equal under interval scale of measurement. If it's along with the difference, unique difference between each values, if we can have multiplication or division, then on the data, then we say it has a scale of measurement as a ratio. Paragraph. What kind of is the question is paragraph ordinal or nominal? So paragraph is like what kind of data are you going to collect it? You're collecting. Generally, if you have paragraph, then it's the unstructured kind of data. So you can't distinguish or you can't have differentiation between the data like when it is unstructured. Hello, am I audible now?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, fine. So do you have any doubt till now like this categorical and numerical data types?
No, ma'am.
Okay. So there you may have seen in today's lecture, we mainly focus on the distribution of categorical data, its representation, and how you will analyze if you are sure that okay, your data is categorical data, and now you have some questions. See, whatever the data set is, its main purpose is to uh, is served when we have some analysis over it, and we come with some uh, either with the summary or some prediction. So we will go one by one. So let's start with the categorical data. So you have a categorical data, then there is a first term which comes is frequency distribution. So you may have heard this word frequency.
Hello, ma'am.
Yes, hello.
Am I audible?
Yes,
Ma'am, is blood pressure interval or ratio?
blood pressure.
Yeah,
Okay. How will you measure blood pressure? Like,
based on the systolics and diastolics,
yeah.
like the
So
ratio we get.
fine. So can you give me just one or two values like as a data, as a
Um,
data?
120, 80.
120, 80, or uh, like generally we give blood BP like this, right?
Yeah,
Yeah.
I
Or
think it should be a ratio, but in the assignment, it's not there.
it's
In
not
the
actually.
assignment, yeah, it's showing incorrect for ratio.
Yeah. You are just saying, you are just see any scale of measurement, we do not, when we are deciding whether your data is of which kind of scale of measurement it has, at that time we do not look how the data is looking like. You may have called it ratio by just observing that okay, your values are like this, right? Or something else. How did you decide this data has a ratio scale of measurement? Can you explain me?
Yeah, because it can be absolute zero. That means the person is dead, and it doesn't have any negative values.
Or it can have negative? Sorry.
Yeah, it doesn't have any negative value. Blood pressure can't be negative.
Okay. Is it enough? Like,
So,
is there any
so if it is negative, if there is a possibility of negative values, could be interval. So in that case,
see,
it could be a ratio.
let's say someone has BP as 120 by 80 and someone has BP, let's say 30 by not 30. Uh, for example, someone has BP 60 by 40. Okay, just for hypothesis, I'm just taking hypothetical values. Okay, 60 by 40. Can you say, let's say this is P1, sorry, P2, and this is P1, fine. Can you say the BP of P1 is double than P2? Or if I change this value as 60 by um, 50, it may be fine. Can you say anything about this P2 and P1?
Um, um, BP is of P1 is more
No, no,
high
no, no.
BP
Whenever there is a ratio scale of measurement, division should be possible, right?
division.
Yes, ma'am.
Yeah,
Division between two data.
yeah.
So, uh, here is it like that? Can we say, okay, P1 has the BP double than P2? There is no such a things, right? See, whenever the ratio scale, for example, I will just tell you, instead of BP, you just compare it with the weight. Or just okay, if it is not ratio scale of measurement, then which kind of measurement it is? That is also another question, right? Hello?
Yeah.
Yeah.
mm, mm, but we are measuring it. I think it's a quantity only. It can't be quality to data, and I think it can't be interval also. Then the final option left over is ratio only.
Why? Let me
Hello,
just check the question. Is there any context to
hello,
that?
ma'am. You are not audible clear.
Hello? Hello?
Yeah,
Yeah.
it's clear now.
See, let's take the example of weight, and then we will go back to BP question. Okay, wait. Let's say if some
Ma'am,
P.
can you speak little louder?
Just a minute. Why it's not being.
Uh,
Is it the problem with
Maybe
everyone?
it's my problem.
Ma'am, your voice is very low.
Yes, ma'am, your voice is.
Yes, ma'am.
Okay,
Oh,
okay. Let me check. Hello. Now is it fine?
Yes, sir, ma'am.
Yes, ma'am.
Okay. So let's say P1 has weight 30 kg and P2 has weight 90 kg. Is there a division possible or not? Like division kind
no,
of thing?
no.
No? Okay. Anyone?
Yes, it is possible. Like we can say P2 is three times more weight than P1.
Yeah. Yes, it is possible. See, ratio means division 30/90. You can have, when you divide this thing, you will get, okay, the weight of P2 is three times more than the weight of P1. This kind of things comes under the ratio scale of measurement. Whenever there is division is possible, and if you have the if you have knowledge that, okay, the weight of P2 is three times the weight of P1, then you can find the value of P1. Find the weight of P2. Similarly, if you know the BP of one person, and there you can't have such a thing. So why? Because it may be possible that this 120 and 60. There may be the difference between two or twice or thrice multiple like that. But simultaneously, this should also match, and actually, there is no some sense like that. So that's why this is not a ratio scale of measurement. Then it comes to whether it's interval or not. So anyone would like to answer? This is an assignment question, right? So and I think the last date is done for assignment one. It was, I guess, 31st Jan.
No, ma'am, it's today deadline.
Sorry.
Ma'am, deadline is today.
Okay, okay. Deadline
No,
is
it was
today.
not.
Then we should not discuss this question, right? Is this a graded assignment?
No,
No.
ma'am. It's from practice.
Practice assignment.
Okay,
Can
okay.
you hear me?
Yeah,
Uh, you can hear me, right?
yeah,
Okay. So first of all, the 60 by 15 never exists. It's
yeah.
not even
That's what
possible.
I just
But if
told.
you
It's a
just consider
hypothetical
about
value.
pressure, okay, pressure, forget the blood pressure. Just consider pressure, air pressure or whatever. There can be zero and it can be twice or
Yeah.
thrice, right?
If yeah,
Similarly, like a person cannot weigh zero. That's not possible. Even
yeah,
a baby, when it comes out, it weighs at least 2 or 3 kgs,
yeah,
right? So if the logic that you're trying to explain weight of a person, if you use the same logic for blood pressure, they don't work. But if you're talking about weight in general of a thing or something, so yes, in that same case, if you're just thinking about pressure, measuring pressure, then you can have something which has double the pressure. There can be zero pressure as well, right?
yeah,
And then also there are other measurements for human beings, like let's say blood glucose level. What about your cholesterol levels? So all of these are never zero.
yeah.
So then would these all not be ratio scale? But they
See,
would be ratio scale.
whenever there is a absolute zero in your data, then we say, and there is a division is also possible, then we say, okay, your data is your data have ratio scale of measurement. So let's start with the weight. If someone, see here, zero weight means no one is there, right? It's absence of person, we can say, absence of materialistic thing, right? So this is what we called absolute zero, presence of absolute zero, and there, and when it comes to weight, multiplication and division is possible. So this kind of thing. So weight has a ratio scale of measurement. Let's come to BP. So not BP, only pressure, fine.
Yeah.
So you just told pressure cannot be zero, right? Or can be zero. What you told?
I mean, like, yeah, if before starting the measurement, like before you start pumping the valve, the measurement reading in that apparatus is zero.
Yeah, and there is a presence of zero pressure. Like it's an ideal according to
Yeah.
physics, but still there is something called as zero pressure. Or I don't know, it will go more technical. But just leave zero because an ideal condition, so we will not consider. But if there is some uh, 30 atmospheric pressure is there at some place and somewhere it is 60 atmospheric pressure, then can you say that this is double than this? Is it true? No, right? You can't say these things that 60 having 60 atmospheric pressure is almost double than 30 atmospheric pressure. Does it make sense? Like even though there is numerically you can say 30 and 60 has some difference, that is twice, right? But this is not true. Similarly, if I go with the temperature, okay, I'm
Okay.
going to temperature.
Yeah,
uh,
temperature we know, like only when it's Kelvin, then it is ratio.
yeah, fine. How do you
Yes.
know that? Because uh, whenever it's in Kelvin, then what, there is some absolute zero thing is
Mm-hmm.
present there, right?
Mm-hmm.
Sorry, yeah, it is present. Zero Kelvin means what? Nothing, right? No pressure. At that time, we will say, okay, uh, having 30 degrees Celsius, okay, I am going to again Celsius. 30 degrees Celsius and 60 degrees Celsius. Can you say something similar to that? Like having 60 degree centigrade is almost double than having 30 degrees centigrade. Okay.
No, because I mean, no, this is not there.
Similarly, in the pressure is also like that. I just
And
check.
what about when you're measuring like blood glucose levels?
Blood glucose level, how do we measure? What's the measure? It's in mg, I guess, right?
Mm-hmm.
Hmm?
Like
Or
any characters, like anything, let's say vitamin D levels, this that uric acid levels. So all of them, neither of them are ratio.
uh, is it so like is there presence of absolute zero or not? That is the only thing. So when it comes to blood glucose level, is it possible that does it mean if blood glucose level is zero, that means no sugar present, no glucose level present? Like in degree centigrade. Sorry, in Kelvin. If it's zero Kelvin, that means no temperature, right?
Mm-hmm.
Right?
Yeah.
But zero degree centigrade doesn't imply that no temperature is there. Zero degree centigrade means something, right? It
Mm-hmm.
has some value. So I'm just asking what this, if blood glucose level is zero, then what does it imply? Does it imply like it's no glucose or like that? So yeah, it's absolute zero, fine.
Yeah.
Because we can't have, see, when it comes to temperature in degree centigrade, negative 30 degree has some sense, has some meaning. But as per my knowledge, blood glucose can't be negative, even can't be zero.
Mm.
So we can say that, okay, there is a presence of absolute zero, and if someone's glucose level is, let's say,
But you can have like double or triple amount. Like
yeah,
some people do
yeah.
have
So that's why
300 and
it's a
some people
ratio
have
scale of
100.
measurement. So let's say someone's glucose level is 120 mg or whatever the unit is, milligram. I guess, yeah, it's in mg.
Yeah,
And
it's millimole per liter, I think.
yeah, and someone's glucose level is, let's say, 60. Okay. Again, I am saying
Or
these are
mg
the
per day.
hypothetical values, fine.
Yeah.
So at that time, we can say, okay, this person P1 has double glucose level as compared to P2. So it's a ratio scale of measurement. So whenever there is a discussion about ratio scale of measurement, we have to check some uh, two or three things. Okay. Ratio scale of measurement. Then first thing is, there should be order in the data. That's obvious because we have seen first it becomes ordinal, then it comes to numerical, then it comes to interval. The difference between two values should be unique, like the constant or same, and multiplication and division should be possible there, right? And the most important thing, absolute zero should be present. Absolute zero is there. Okay. What does it mean by absolute zero? Absolute zero means if your value, whatever your data is, if the data in case it it gives you a value zero, then it should imply that uh, the absence of the variable whatever you are calculating. Okay. For example, blood glucose. If someone has put it as their blood glucose as zero, that means absence of that thing.
Yeah,
Okay.
but like
Am
if you're
I
just
audible?
measuring glucose, like in a solution, you can have like zero glucose in a solution.
Yeah. At that
So, I
time,
mean, the thing is like once you say blood, does
yeah,
that change
yeah,
everything?
that's why. If it comes to a glucose level in a water, fine,
Yes, yes,
and just a solution where you are checking glucose level, fine,
yeah.
and it's giving you, okay, uh, the amount of glucose in certain solution is zero. Does it
Mhm.
imply the absence of glucose in that solution?
Yes.
Yes, so it's absolute zero. Whether it's a blood glucose or whether it's a uh, glucose level in count of glucose in certain solution, at that time zero indicates absence of glucose, fine.
Yeah,
This is what called as presence of absolute zero.
correct.
So
So what
whenever
happens when there is a vacuum?
in vacuum, when
Yeah.
it comes to pressure, right,
Yes.
because we can't have this thing, because zero atmospheric pressure means vacuum, right? Vacuum, whatever we say it as a ideal condition again, right?
Mm-hmm.
According to physics, where the pressure is, how do you explain, if you have to explain, let's say some child, what is vacuum and what's the pressure there, then how will you explain it? You will say vacuum is a condition where the atmospheric pressure is zero, fine.
Mm-hmm.
Does it mean the absence of pressure? No, right? Some pressure, like atmosphere is there, but it is giving value zero, like degree centigrade.
Okay.
Are you getting my point?
Okay.
So that's why when it comes to pressure, it is not ratio scale of measurement, but when
So
it comes to,
pressure, whether blood pressure or any pressure, is always an interval scale.
yeah, it's always interval.
Okay. But so, and when you come to glucose level, if you say blood glucose, then you will say it is interval,
It's
and
a
just
ratio. It's
blood
a ratio.
glucose,
Blood
glu-
glucose, yeah.
blood glucose also,
Yeah, because
because it won't be
absence,
zero.
yeah, because even if it is zero, absence of glucose, right? Or like when it comes to some, like I don't want to comment anything on this blood glucose because it may be some technical term, right? blood
Yeah,
glucose level.
because
Like
it's
I
never
don't know
zero.
about the biological or medical things, so I cannot think I think I should not say anything about this. But glucose level I can say. Glucose
Yeah,
level in a
glucose level,
solution,
of course, it can
in
be
a
zero in a
solution,
solution.
right?
Yeah,
In
true.
any solution.
Right.
Then I can comment something.
So my main thing was like pressure or blood pressure, any kind of pressure. So even if you're artificially like just pumping pressure and checking uh, maybe how strong something is, that all of that is under interval. It's not a ratio. And on the other cases like glucose solutions and this and that, they will be ratio, right?
Just a minute, just a minute. Can you repeat again?
I'm just repeating like the conclusion of
Yeah.
the discussion. That is that if we are just talking about pressure, blood pressure, or any artificially given pressure, um, right? That I'm sure for mechanical testing and all, some people they will give some more and more pressure.
Yeah.
Let's say in a car tire also, that you can keep on filling air and increasing the blood like the pressure. So all of that is interval.
Yeah.
And but let's say for measuring glucose levels, vitamin D levels, uric acid levels, this
See,
and
see,
that.
see.
So
I just told you. I can't comment on any like medical terminology.
yeah,
So, like I would say
okay.
the thing about which I do not have precise knowledge, I should not comment
Mhm.
on it, right?
Okay, okay,
But I can say about pressure,
okay.
in general pressure, uh, count of glucose in any solution, or weight, height, this kind of thing, where I know there is presence of some absolute zero, not pressure. Okay, uh,
Yeah.
that's what at that time
Because that is
we say
exactly what,
data has scale of
for me,
measurement.
it was like if you're talking about body weight of a person, then it's a bit different, or even height of a person for that matter, because
Yeah,
a person's height can never be zero.
yeah.
But we still
So it's
consider
just
that
so
height of a
whenever you
thing can
can,
be zero, or weight of a thing can be zero, but not that of a person.
yeah,
So if you just go deep inside, that gets a bit tricky.
yeah,
And regarding the ratio scale and all, I feel like the discussion where we had stopped last time was that like a statement that you had made was that ratings can be either ordinal, interval, or ratio
yeah.
scale,
That's why I just start.
depending on the scenario. And then someone had asked you to give an example where rating can be ratio, and you said that
Yeah,
you'll come back
example.
later with an example.
Yeah.
So
So I just like corrected myself in the
that
starting of the answer
rating can
only.
only be
Ordinal
ordinal
or
or
interval.
interval, not ratio, right?
Yeah,
Okay, thank you.
yeah. Fine. Okay. So, hello. Like someone is complaining, my voice is not audible. Is it so?
Now it's okay.
Okay. See, streaming will be available in some time. Uh, you can find it. Okay. So let's start with the week two content. If there is any there any doubt, please tell me. Like, or we should start with the week two.
And why does absolute zero matter only in ratio scale?
See, when it comes to division, at that time, like I just don't know why. Division. Okay, whenever you are dealing with the division, uh, zero will not. Zero will create more and more problem for you, right? And the thing behind to have to consider absolute zero whenever we are talking about ratio scale of measurement is that if you have like it's kind of thing that whatever you are measuring, uh, it should have some realistic value. That's why we are more focused on absolute zero, because whenever you say the whatever you are, let's say you are calculating some uh, x kind of x factor, okay, uh, you are collecting some data, and there you have one variable, let's say variable 1, okay, and you want to check whether it's ratio whether this variable do have ratio scale of measurement or not. At that time you will check, okay, uh, you will measure for the cases, right? If this variable 1 is taking value 0, that means this case 1 do not have that factor. That means absence of this v1 factor in c1 implies the value 0. uh, and c2 has, let's say, some value 20, and c3 has some value 40. So at that time, you will not be able to compare between C1 and C2. Will you be like, let's say these are some kind of variables, these are some measurements you have, you come with when you were collecting the data about some blah 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 factor, fine, and you come with this. At that time, if 0 is present, let's say if 0 is present, at that time, can you conclude about, or can you make conclusion that this C2 is 20 times than the C1, or C3 is some 40 times than C1? No. Why? Because in ratio scale of measurement, right, we can't say because of this 0. And in ratio scale of measurement, we say that whatever the data is, we should be able to make division and multiplication operation over the data, fine. So whenever 0 comes into the picture, this division will be some problematic. That's why we do not want it. Again, this is one reason. And another one is, the data is not just a number. It's not just a randomly chosen number, randomly, uh, like we have not filled the table randomly when it comes to real time data or real life data. These values have some meanings, right? It's not just number to calculate it and have some analysis. It's some experiment over from which these data are collected. So it has some sense, it has some meaning. That's why when it comes to uh, some measurements, in that measurements, there is something called absolute zero, which means whenever you come with the zero, that means absence of that particular factor. And this is what, when they might have studied this scale of measurement, they have noticed that, okay, like data having absolute zero may have ratio scale of measurement. Are you getting my point?
Yes, ma'am. But if you take the example of marks, still we can compare that C1 has got 0 marks, but the C2 has got 20 more marks than C1, and C3 has got 40 more marks than C1.
Yeah, yeah. So whenever see, you are talking about marks. So in terms of marks, okay, you can relax that condition. Absolute zero condition, okay, someone can score 0 also, right? If he or she do not write anything, then score will be 0. At that time, uh, like there is something called data cleaning is there. So that will come later. But yeah, absolute 0, you can relax in, like, whether, I am not sure whether I should say that or not. If it is marks of a student, then obviously it is a ratio, it has a, sorry, obviously it has a ratio scale of measurement, and also it can take value 0 also. So like what was the problem there? Hello.
Ma'am,
Yeah. No, like
is it
someone who was
necessary?
talking about absolute zero. Just a minute. I'm like, I just told, uh, whenever it's data collection, it's not just a random number. It has some sense. So sometimes, let's say you are calculating marks, then even though zero is present there, you can say that this data has a ratio scale of measurement. Yeah. The next one, what you were talking.
Ma'am, is it necessary for all headers of the tablet data to be variables?
All headers.
Yeah,
See,
yeah.
uh, it's uh, it's like whenever data, that's what data is not something you just have. It's like it was collected, then it was tabulated. Fine. So once it tabulated, and you have to generalize the things, then you have to say, okay, this marks, weight, height, BP. You will say them. You have to name it, name this thing in general. So we will say them as a variable. So it's what? Are you getting or what?
Yeah, but if it is something like comments or suggestions, locality, but
Uh, then
they are
also,
not variables.
uh, then also we can say them this is a variable, but when it comes to comments, then it will be a unstructured data, but still you can have, you can say it a variable, right? It should, what does it mean by variable? Like it's, that's as simple as that.
An
The
entity that
values that is
may
varying.
vary.
Yeah, that's all. So, this case is like whatever the table is about, you have cases and you note various data, various information about them. And whatever you are noting down, we say them as a variable. Whether it can be marks, locality, someone's address, or whatever, mobile number, and whatever. It's just a generalization that we have, um, like we have nominated them as a case about which we are collecting the data, and rest of the thing as a variables. Okay. Any other
So there
question?
is no need to technically consider them as variables. All headers are variables, right? In that case.
Uh, See, it's just a generalization. Here, when I
Okay.
was giving this example, at that time, I was not taking any particular context. So I just took variable one. And then later I said, okay, someone has asked me to take marks. So I just take variable one as a marks. Okay, fine. So should we start with week two? Or if there is any doubt, we can have that also. No problem.
Ma'am, start me too.
Okay.
Ma'am,
Yes, ma'am.
Okay, fine. So in week two, you are like we will be having categorical data and description of that, or how to describe them. So first, we will come with the term frequency distribution. So have you heard about what is frequency? Not that physics one. Yeah. Even though in physics, yeah. What is frequency? Do you have some any idea about the frequency of
How many
anything?
time a item occur, ma'am?
Yeah, occurrence of something, right? Kill data, we will see that. And first thing we are looking is frequency distribution. So when it comes to distribution, That means we will have some data. Obviously, that data might be a nominal or ordinal, as we are dealing with categorical data as per this lecture or whatever. Yeah, this week 2 sessions. So, whenever you have a quantitative data, you will list distinct values of them that's present in your data, and you will count the number of times they are occurring. That's what we are saying them as a frequency distribution. So on the very basic level, we will have a table like distinct values, whatever your data is taking, you can say it as a category also. Fine. And this as a frequency. Fine, count of that data. For example, let's say um, there is some meeting of let's say schoolmates are there, and you have formed a committee with the uh, like 8 9 10 standard students. So there are some 10 students from 8th class, and some 20 students from 9th class, and some again 10 students from 10th class. So this is directly like frequency distribution, right? uh, So, can you just tell me, like, what will be your distinct values, and what will be your frequency in this sense? If I say, in a school meeting of, let's say, some cultural things, you have culture for some cultural program, you have formed a committee of student, and in the committee, this is the data you have. Some from 8th standard, you have some 10 people, and like that. So, can you make a frequency distribution for this kind of things? So yeah, yes. So which will be your categories and which will be your frequency?
The
Category
standard
in this sense is the standard people from which, yeah, yeah,
Eighth,
standard
ninth, and
frequency
tenth.
and
8, 9,
It's
10,
a
and
respectively.
your frequency for that thing will
10,
be
20,
10,
10.
20, 10. Fine.
22.
Yeah. So continuing with this example, I will just introduce another thing, that is relative frequency. So, whenever there is a term relative there, what does it mean? Relative frequency. S- relative to the something. But when it is precisely with the frequency or any particular thing, that generally relates to the total of the uh, data. So, what's total here? Uh,
40.
it's 40, right?
It's 40.
So, like, do you have any like? Can you just tell me why, if you have frequency already, why are you looking for the relative frequency?
We can compare easily.
Why can't you compare with this directly with values?
Because frequencies can be different,
Uh,
but the relative frequencies might still be same, even if the frequency values are different and the total values are different.
but still, I will ask why? Why? What's the need?
Ma'am, to know about the share of proportions.
Yeah,
Okay.
because total relative frequency is one
Yeah.
always. So it helps you to understand if you're like trying to compare two different things and how like different elements are like different, then you can use relative frequency. For example, if there is 10 20, and in another case there's 20 40, though the frequency counts would be different, but um, if you
Distribution is
see,
same.
yes, yeah.
Yeah. Yeah. Yeah.
Ma'am, are you
Correct.
talking about cumulative frequency?
No, no, no. As of now, only relative frequency.
Okay.
So what's first we will discuss what is relative. Yeah, the need for relative frequency, as you guys discussed, is correct. We need it for the generalization kind of things. Let's say for this particular data, when you have a school committee where 40 people, 40 students are there, and you have this as a count. At that time, you may have some XYZ relative frequency, fine. But and then there is some another situation, another context where is some let's say societies are there, and they have made some committee, and there is some distribution, there is some, yeah, distribution about the peoples from the same floor or like that. At that time also you will have some numbers, and let's say counts like some 50 peoples are there in a committee, and here some 40 peoples are there. Still, um you have to show the distribution for that thing, and here also there might be some similarities and some in general things you can talk about. At that time you need relative frequencies. Fine. So how will you calculate relative frequencies? First we will check that. So yeah, so this is nothing but the ratio of the frequency of particular category, frequency of let's say particular category, and you will ratio with it total total number of observations. So like isn't it looking like a fraction of something observations? Let's say there are some people from 8th standard. uh, So whenever you want to generalize these things, I will ask you what fraction of students are from 8th standard. Then how will you answer me from this data? At that time also you need relative frequency. Fraction means what? The thing or kind of percentage. How much percentage of student are from class 8? Then you have to go with the relative frequency. How will you go with that? You just find, okay, you have 10 students from 8th standard and total students are 40. So 1/4, that means 25%. Fine.
0.25.
Yeah, 0.25. So you can say, okay, in this committee, 0.25 fraction is from the 8th standard. And again, this will be 20 by 40. 50% of the students are from class 9th. Right? Can I say it is it as a 50%, 25%, and again 25%? Is it fine? Do you agree with me? Can I say
Yes,
that in a committee 50% students are from the ninth standard?
yes, ma'am.
Fine.
Yes, ma'am.
Yes, ma'am.
So why it happened here? Like that's what the beauty of relative frequencies. You can directly check what fraction of the particular category is in a whole domain, in a whole data. Fine. That's why we need relative frequency. Or in general, when you come to a bar chart and a pie chart, at that time also, sometimes you will have a need of frequency, and sometimes you will go with the relative frequency. Fine. We are going to discuss that on. So, there is some things to notice. That is, the sum of the relative frequency is always 1, and the values of relative frequencies lies between 0 to 1. Fine. Why it is so? General mathematics, right? Because if you are dividing something from the total, obviously it will take values between 0 to 1. Isn't it?
Yes, ma'am.
Yeah. Yeah, right.
Yes, ma'am.
Fine. So let's go to the distribution or charts for the categorical data. So which charts have you studied?
Ma'am, both.
Okay, pie chart and bar chart, right? So
Parota chart also.
yeah, categorical data. So first one is So yeah, pie chart is there. So what is pie chart? So pie chart is nothing but you have like along the circle, uh, we represent it like a circle. Sorry, it's not that much perfect. Just see. Okay. You will have some kind of circle, and what's the purpose here? You have to plot whole your data in this pie chart. You have to put it like that. So, uh, in circle, the number, what's the total number of degree, right? Angle, if you measure, it is a 360-degree, right? And now you have to uh, fit this data, this what we have studied here for the like student committee. If we have to check this things, we have to put these things in the pie chart, how we will go. That example is so simple. It is like very easy to have 25%, two portions of 25% and 25% and one portion of 50%. But let's go with the degree things. How will you start with that? You have to form the pie chart using that data. How will you go with that? So we
Ma'am,
just,
find
yeah,
ma'am, find the relative frequency and multiply it by 360.
yeah. So we have three categories, right? Some 8th standard student are there, 8th, 9th, and 10th. Fine. So let's start with the 8th number of 8th class student. So 10 students were there, and the relative frequency was 0.25. You will just multiply it with 360, and what it will give?
90.
90. Fine. So this 90 you will go with this, and this will be your uh, portion for the 8th class. And similarly for the 10th, and remaining is for 9th, right? So that's what the pie chart is. Uh, so relative frequency we can use we can take use of relative frequency and make the pie chart here like that. You may have seen in the news channels also, when there is a election things are going on, you might have observed that this kind of charts are there. Have you noticed
Yes,
this?
ma'am.
Right?
Yes,
So
ma'am.
this is what there are some crores of people voting for the parties, and they show the whole things in a pie chart. How is it possible? Right? We are like crores of peoples are voting, and they just summarize all the things in the pie chart or bar chart, right? How is it possible? This is possible just because of that relative frequency kind of things. We can have whatever the large number, like how much the big number is, but you can still have.
Ma'am, your
Uh,
voice is less audible.
oh, sorry again. Is it okay now?
Yes, ma'am.
Yeah. So that's what how like I just told you whatever the real life situation whenever you have observed this pie chart. So after that, there is bar chart. You have seen that also. So in bar chart, there is one thing. What? It is the easiest chart you can plot, right? If you have the proper numbering of things, you have
Yes, ma'am.
then you will, the basic graph that you can learn is bar chart. Let's say 0 is there, 10 and 20. Again, the same data of that school committee. Uh, then here will be 8th, 9th standard and 10th standard, right? At that time, what bar chart will say? For 8th standard, you have some 10 peoples are from there. So there will be a bar like that for 9th and again for 10th. So that's what bar chart is. So Can you just tell me when to use bar chart and when to use pie chart? Like, what's the difference and why at some point of time you will go with the bar chart and sometimes you will go with the pie chart. Why is it so?
Yes, ma'am. Yes, ma'am. Bar chart is used to compare the different groups, and while the pie chart is used to just define the share or proportion to the total proportion used.
Yeah. Okay. Yeah, that's fine. So whenever you want to directly compare the two groups or two categories, because as we know, this is nothing but the like considering the students from 8th class, 9th class or 10th class, this is nothing but we have categorized the student based on the standard they are studying, right? So whenever we want to check the comparison between the categories, or at the time we will go with the bar chart, but whenever you want to go with the fraction of something, or you want to compare any category with the whole part of the data, at that time what will you suggest? Yeah, that will be a good question. Let's say you want to compare. See, bar chart is used for comparison, but when pie chart is also used to comparison, but when uh, are you getting my point? Let's say you want to compare.
Ma'am, can you please check your microphone?
Okay,
Yes, ma'am.
just a minute. Hello, is it fine now?
Yes, ma'am.
Okay, okay. So let's say you want to compare the category that is 9th standard student as a whole, then you have to go with the pie chart. Why it is so? If I whenever you want to compare two categories, okay, I'll say whenever you want to compare two categories, let's say number of students from 9th standard and number of students from 10th standard. Uh, what will be your one line statement for that thing, like for 9th and for 10th class student? What can you say? That we can say like that, okay, in a committee, uh, number of uh, number of students from 9th standard is double than number of students from the 10th class. Is it will it
Yes,
be the right statement? And similarly, if we want to compare the number of students from 8th standard and 10th standard, then what will be your comparison statement for them?
ma'am, they are both same.
They are both same. But let's say I want to ask you, uh, make a statement for 9th standard, number of students from 9th standard in a committee as a whole, like as a whole committee. Then what would you comment on that? Can you,
Ninth standard students are 50% to the
sorry,
whole.
can you repeat it?
Ma'am, ninth standard students are 50% to the whole.
To the whole. From where did you get to know this? Like, can you say the same thing from the bar chart?
Mm, no, ma'am.
See, this is I accept this is so easy example. You can directly add them 8th and 9th standard and can say. But the same thing, if you look here at this pie chart, at that time you will see the 50% of the committee is from the 9th standard class, right? 50, 25, 25. That's it.
Yes, ma'am.
So, yeah. So when you want to compare any particular category with the whole data set, at that time you will look for the pie chart. Otherwise, you will go with the bar chart.
Chart.
Fine. See, this data was actually really easy. But there will be some data where from bar chart you will find it difficult, or it's not visible sometime with bar chart, so you will go with the pie chart or alternatively. Okay, fine. In bar chart there is one more thing, that there is no sequence of these things, like see this eighth standard student is bar height is 10, then the bar for the ninth standard student is more than the eighth, and again then it's decreasing. So whenever you are creating bar chart, at that time this sequence doesn't matter. But at some particular chart known as Pareto chart, that is so special, that in which this is a just a special kind of chart in which the highest frequency will come first, and you have to maintain uh, order here. It will start from the highest one and then go with the decreasing order. So similarly, if you want to plot the same graph as a Pareto chart, then what will you do? Again, the same thing, 10, 20. And then here, the first one will be, yeah, hello?
Ma'am, ninth.
It will be a 9th, right? Highest one.
Ma'am,
Yeah.
ma'am, we can start from lowest also, right?
In Pareto chart,
Yes, ma'am.
is it so?
Ma'am, in activity
Hmm.
question, it is.
Okay. Just give me a minute, okay? So in Pareto chart, yeah, basically there should be a sequence. That's it.
Yes, ma'am. Maybe ascending order or descending order.
Yeah. Fine. So generally, we perform this one, descending. Why it is? Because there are some, what we say, there are some things that we used to follow. Like it's general notation. Like some people even use increasing also. But there is some benefit with the Pareto chart that we will learn in this session only. That is mode. That is easily we can find with the Pareto chart. Yeah, someone was asking something. Yeah. Hello. Okay. So after that, yeah, there is some mistakes that we should not commit when we are performing this, when we are having these charts. So first of it, first one is like sometimes some graphs are like that. Let's say this graph, they represent like mm, the data is like from 10 to 20, they are saying. At that time, this is what shifting of numbers. So whenever you are having 8, 9, and 10th, at that time, you will say, okay, 8 is here. Your graph is like that for here. And
Ma'am, your voice is very low.
yeah. So, sorry. Lights. mm, Hello. Yeah. So if someone is shifting the numbers from the chart at that time, some misleading information can be carried out from here. Like from this chart, if someone has to compare the things with the number of students from 8th, ninth, or 10th, at that time they will say, okay, the whole committee is from the ninth standard. Isn't it like, is it looking like that? The whole committee, all the members are from ninth standard. But when you see the graph like this, at that time you will find, okay, no, it's not like that. It's just misleading because of this shifting of numbers. Fine, this kind of errors will be there. And one of the common error is that a rounding of the numbers. So sometimes the data will be like in decimal format. That one example ma'am has taken in the class. I will check with the other. Let's say there is some data. Let's say categories are like A, B, C, D. Categories are, and their frequency is given there. Frequency is given there. Like let's say category A is contributing like 74.5%, and category B is, let's say, 20%, 20.18, and C1 is 5.5. And someone is rounding off it like 75, 20, and again 6. At that time, what's the main problem like with frequency? At that time, if you go with the pie chart, there will be one problem. Can you notice that? Like, just sum up this thing, we will have, yeah,
Yes, ma'am. It adds up to 101.
yeah, it's adding 101, and it was not 101 if I remember, if I, yeah. But when you add these things, at that time, it's not that, it's what, 75 plus 5, 80,
99.28.
yeah, sorry, 99.18, 18 or 28,
28.
yeah. So that's what, when you create the, like whenever you rounding off anything, just check with the frequency. That should not, like, the total should not change. That is called a rounding off error. You will find some problem on activity question regarding these things. So just to be careful about that. So this kind of errors are there. Then, yeah. Then there will be some misleading charts also. That's what this kind of error we generally say, like, not error. We will say that whenever you are describing any chart or representation, at that time it should follow area principle. What does this area principle says? It says that, uh, sorry, it says that whatever you are representing in terms of chart or pictorial form, it should represent the like part of the particular category, how much it's contributing to the total, um, at the whole data set. Like in the lecture series, you have seen that something like, let's say someone is representing this, I can't without picture, right? Okay. Let's say someone has drawn the pie chart in front of you, and they have given that, okay, um, they have mentioned A, B, C. Okay, this kind of thing they have given, and they have represented that A is nothing but 30%, C is 20%, and B is 50%. Then this is also not following area principle. Why it is so? First of all, they have not followed the rule, right? This was just a representation. I should not say the pie chart particularly. Uh, I can say like this. They have represented something like something in this. What we say, this kind of stuff. They have, yeah, quadrilateral. Uh, they have presented it like that: A, B, and C, and they are giving percentage like this, then from visually also we can say that okay, this is not, this B and C are almost looking like equal, so it's not following the area principle. What area principle says that whatever the percentage or whatever the fraction it's contributing the particular category, it should be pictorially also it should look like that. Are you getting my point? Like if this kind of presentation is there, it's not valid, it's not correct, because it's not following area principle. So these were some rules that you have to take care whenever you study any graph or particular any charts kind of things. Fine. So after that, the main topic is measure of central tendency. So this is what, from where our main syllabus starts with. See, in the first lecture, I have told you there is, when it comes to statistics, it's mainly divided into two parts. Anyone remember what were they?
Inferential and descriptive.
Yeah, inferential and descriptive. So, whenever you study descriptive statistics, the first description that is very common to study about any data is, first of all, we study about central tendency of the data. For what is central tendency then? The central tendency is what, some kind of parameters that will give you some insights of data, how on an average or how centrally it behaves, how the behavior of the data is. So this kind of measures are measures of central tendency we will study. So first one we'll study is mode. So just be careful. We are in categorical data. Fine. In next session, when we will have numerical data, we will come again with the mode, median, and all these things. But as of now, we are in categorical data. So mode. What is mode? Like mode is one of the measure of central tendency.
Frequent item.
It represents highest the category with the highest frequency. Fine.
Yes.
Okay. So with this example, can we find mode of the data? Yeah, this one.
Ninth.
Yeah, fine. So when it comes to mode, how will you calculate it? The first question is how will we calculate? The simple task is calculate the, find the frequency table and check which one is the highest. That is your mode. Fine. Is the voice clear now?
Yes, ma'am.
Okay, okay, fine. So mode is for whenever we are in categorical variables, the mode is nothing but the category with the highest frequency. Mode is nothing but highest frequency. Fine. So, for example, that again, that uh, example only 8, 9, 10. So, as you told, the mode of that example or mode of that committee will be ninth. Why it is so? Yeah. Yes, what you were saying. 8th, ninth, and 10th, let's say.
Ma'am, we find average of the data in inferential statistics also, right?
Inferential is somewhat different. That even I'm not sure. That is not even in your statistic one course.
Okay.
It's somewhat different things. Uh,
Is it in
It's not like that.
Statistics.
We even calculate mean using inferential statistics, but that's a totally different story. See, whenever we are in descriptive statistics, we work with the data, whatever we have in our hand, and we will tell everything about the data within the data. Fine. But when it is inferential, we will predict something from the given data about which is not in your data set at all. That's a
Mm.
complete different story. But yeah, from week 6 onwards, you will get some ideas about inferential also, that how it is different from descriptive. Uh, so first is like, as it is the start of the course, we will learn how descriptive statistic works, and whenever the things like descriptive study, like we said, like in last lecture we were saying what is descriptive statistics. There were some statement in your assignments that whenever we are summarizing the data, it is called descriptive statistic. The thing is, the question is, how will you summarize the data? There should be some measure, right? There should be some parameters that should describe something about the data. So as we are in the starting mode, we will like first learn about the parameters like mean, mode, median, and then we will say how it will describe the data. Fine. So here the first basic things about that is mode, which just simply says a category with the highest frequency is the mode of the data. Fine. So with the bar
Yes, ma'am.
chart, pie chart, okay, how will you find from pie chart what is your mode? Let's say you have not given this table and you just have, let's say I will give you one pie chart, and here is some data A, B, C, D, and you just tell me what
the
is your
category with most relative frequency?
B, C, and D. So if here I will ask you what is mode from this pie chart, can you tell me?
Ma'am, D is the mode. Ma'am,
Yeah, D.
D.
That means the portion with the
Widest, right?
huh? Sorry,
Widest is slice.
why that is like that? Is was it your question? See, category with the highest frequency is your mode, but when it comes to pie chart, um which one, like here we have relative frequencies, right? So if, let's say, if some particular category have highest frequency, then obviously its relative frequency is also going to high, and once its relative frequency is going to be high, its portion in the pie chart will be larger than any other portions, right? So that's why from pie chart, if you have to calculate which is your mode, then you will just look up the portion which is highest among all. So in this particular case, it is portion for D. That's why D is your mode here. Okay,
Yes, ma'am.
fine. Then, like, okay, it may be possible, like, not possible. It may be possible that in some examples like this, there is some categories in which like there are some categories which has same counts. Here if I change the data slightly, like let's say I'm changing the data, like for 8th standard there are 30 students, and from 10th there are 30 students again, then what will be your mode here?
It is
Ma'am, this is
bimodal.
bimodal data.
Yeah, bimodal data. Then what will be your mode here?
8th and 10th.
10, 10.
8th and 10th both, right? 8th and 10th both. That, what does it imply? It implies that a data set can have more than one mode. Even is it possible this kind of data? Say, is it possible or not? If the data is like this, is it possible?
Yes, ma'am. Yes. Yes, ma'am. It is
So
multimodal. Possible.
yeah, it's a multimodal data. Okay, so in that case, your mode will be 8th, 9th, and 10th, all three. Fine. So in general, if I ask you one question, okay, first let me complete the median also, then I will ask you a question at the last. Then there is one more thing, median, right? What is median?
Middle most observation.
Sorry, most what?
Middle most observation.
Middlemost observation. So
The
let's
entity
say
that divides the whole data into
whole data into two. Fine. Okay. Let's say I have some data like let's say there are some peoples from, okay, like there was some survey, and they have found the percentage of like graduated people of that particular part of the country. So they had data like from north, some 20 peoples were graduated. These are your categories, and this is your frequency. Then just check the median and mode for the same, and let me know. Okay, this is north, west, south, and east. Fine. Is it fine if I write NWSC? Fine.
Yes, ma'am.
From west, let's
Yes,
say
ma'am.
10. This is just a hypothetical data. Okay. And from S, let's say there are some 30 peoples, and from E, there are some again 30 people. Then what can you say about the mode and the median of this data?
Ma'am, mode is south and east, but the median is does not exist.
Median does not exist. Okay. Anyone else want to say, comment on this thing? Fine. So when it comes to mode, you will just look at the category with the highest frequency, that is south and east. So that is your mode, but median does not exist. Why? It is also, median is also a measure of central tendency, which will give you the middlemost value. But when?
Ma'am, when it is in
When the
order.
data is ordinal.
What in order? Like frequency or category or what?
Ma'am,
Order.
when category is in order, then median will be fine.
Then for this particular problem, can you find the median for me?
No, ma'am, because they are not in order.
Why it is
And
so?
is not is
Category
median.
variable should be ordinal.
Yeah,
Yeah,
this is a nominal variable, that's why.
that's
For
what I
nominal
want.
variable, median doesn't exist. Only for ordinal variable, there is you can calculate median.
Yeah,
Yes,
that's
ma'am.
what I
Because
wanted
for
to
the
listen
median,
from you.
you first have to arrange them from in a like from smallest to highest. So in an increasing order, and then based on if it is a what do you say, even or odd, then you'll have to, like if it's an odd number, then you find the middle value by
Yeah,
n plus 1 by 2th observation, and if it is even, then it's n by 2 plus n plus 1 by 2, the whole 2, that would be the middle observation, and that's the median.
yeah, that's the average. When even odd, that's a different story. But for this particular data, why we are not able to calculate the median, that's the reason is the categories here are nominal. Like this data is no this are the nominal variable, and when there is a nominal variables, it do not have any order, and the first step to calculate the median is to arrange whatever your data is, arrange in ascending order first. Ascending or descending, your choice. But first arrange it. Then you have to pick up the middlemost. If the number of observations are odd, then obviously there will be a one number which will be in middle. That will be your median. Otherwise, you have to take the average, or accordingly you have to decide what is your median. So, this is the first thing. This is the first time you are come up with the like scale of how the scale of measurement of data plays a role, isn't it? Like till now, whatever we have studied was common to everything, right? You were not worried about what kind of variable your like what is the kind of variable your data has. But when it comes to median, you have to take the worries about the uh, like category of your variable. It is nominal. So if it is nominal, you can't order it, and you can't have the median measure of, right? You can't have measure median when your categorical data is of nominal kind. Fine. So here median does not exist. So now we are like leveling up. Till now we have studied the measure like scale of measures, nominal, ordinal, interval, ratio. One by one, we will cover all those. See, when it comes to mode, whatever the your category, like whatever your data type or scale of measurement for the data is, you can always have mode of the data. Fine. But when it comes to median, it's not like that. You need some orders. Fine. So for median, the data should be ordinal. Fine. After that, what was there? Yeah, I was about to ask one question, right? Do you need any example for the median to be calculated? Uh, then it will be like, let's
Yes,
say,
ma'am, the size of the t-shirts.
yeah, that ma'am has taken in the lectures, right? The size of the t-shirt, let's say. Uh, Shirts, fine. There are some small, medium, and large, and the counts are like, let's say, 10, 25, and 30. Then what will be your median? Oh no, I already gave you sequence. Fine. Then what will be your like median size?
Medium.
Medium, right? But if I give you moderate changes now, what median here for this data set?
Ma'am, medium and large both.
It's not both. We say it like median can be either medium or large. Whenever you study any data, you have to summarize it. At that time, median value will be unique. So, whatever the analysis is, once you have to carry on your analysis with medium, and once you have one, you have to carry with the large. Okay, you can't have both, and here you can't even take the average of them also. So we say that median is either medium or large. Fine.
Okay, ma'am.
Okay. So my question for you guys was uh, just take the numbers from like all the numbers 1 to 100, And what is mode and what is median here?
100 is the mode.
Sorry?
100 is the mode.
Ma'am, it is multimodal data.
Yeah. But the question is, what is mode? If you have to
Ev-
feel
Every number is mode.
every number is mode, right? 1 to 10, 1 to 100. And what is median?
50.5.
50.5. Fine. If I add something in this data, then will the mode or median or both will get affected?
Yes.
Like what quantity will get affected and which one will not?
Ma'am, both one can get affected.
Okay.
Middle
Uh,
and more.
let's talk about median. Will the median will get affected if I add something here?
Yes, ma'am. Font.
Okay. If I add, let's say 101, then what will be your median? Obviously, yeah,
51.
51. It will get affected. Fine. If I again add anything, then like something from 1 to 100, let's say 50 only, then what will be your mode and what will be your median?
Mode will
Ma'am,
be
50 will
50.
be mode.
Yeah, mode will be 50. And what will be your median?
51 will be median.
Are you sure? Just
50 will
reconsider.
be the median.
Yeah,
50 will be the median.
yeah. Why it is so? Because whenever we go for the calculation of median, we have to rearrange the data. We have to arrange the data in particular order, and then we have to take the middlemost. Okay?
Yes, ma'am.
Is it clear?
Yes, ma'am. Yes,
Okay.
ma'am.
You can
Ma'am,
have many manipulation with the data. Yeah.
and 51th observation is 50. That's why median will be 50, right?
Yeah. When you go with the, yeah, 50 month observation is 50. That's why 50 is your median. Otherwise, fine.
Yes, ma'am. Got it.
Okay. If again I will add to this data two numbers, let's say 1, 1, then what's your mode and what's your median?
And 1 will be mode.
Mode will be 1 and median?
Maybe 49.5.
Are you sure? Just take
60.5.
the numbers are even or odd.
52.
It is even.
Uh, the numbers are from here, right? 1, 1, 1, 1, 1 till 50, right?
52.
Okay. Just wait for others.
Ma'am, 50.5.
52.
Okay, let me just write all the possible answers. Okay. 52.
Ma'am,
Another one said 50.5, right? And next.
ma'am, it is 1 1 and after that 1 to 50, then 50. Any changes?
No, no, yeah, this one. Data is this one only. 1, 1,
Okay.
1, 1, 1, 1 till 100, then till 100, then 50. This is your data set. What is your uh, mode? What is your median? Mode, directly you told me 1. What is median?
47.5.
Sorry?
47.5.
47.5. Okay. These are all possibilities, right? Not possibilities. These are the answers given by you. Maybe. Yeah, anyone?
51.5, ma'am.
Okay, 51.5. Okay, as we are running out of the time, I will say how to go for it. So how many numbers you have? This 1 to 100 are hundreds, then 101, 102 and 103.
103.
First of all these 0.5 answers are wrong, right? Because when you have 103 data points, then your answer can't be like this because all are the natural numbers, right?
Ma'am, we have 102 numbers now.
Sorry,
We have 102 numbers.
how? 102? 3 ones are there. 1, 2.
Oh, okay. 3 ones are there. Sorry, ma'am.
Yeah. So if you if you want to give one more trial, then I will wait for 2 minutes
Ma'am,
again.
52.
Ma'am, it's 50.
50 to 50. Okay.
50.5.
50.5. See,
52.
50.5 who has answered? I just have give you one hint. When you have 103 data points and all your data points are natural numbers, then how are you coming with the 50.5? It will be a middlemost number.
Ma'am, 51.5 as the middle number comes, but it is the frequency number. No, oh, sorry, observation number. So we have to see by the frequency which numbers comes.
Yeah.
So
50.
one number before, one or
Okay.
two numbers, I guess.
Yeah. So
The,
what should be it?
ma'am, the answer will be
50.
53rd observations.
Yeah, that's what the question is. What is median?
Sorry, 53th, 52th,
Yeah,
52th
whatever the
observation.
It
observation
is
is.
50.
50, madam.
50.
Okay.
No, it's point.
Okay,
It is
I will
49.
just give
But
you.
but there is like 1 and then 1 to 100, right? Which is written on the screen.
Yeah.
There are
It's
3
1
ones.
and then 1 to 100. So the total number will be 102, no?
Yeah.
I'm turning 52.
51.
Okay.
The
51.
answer will be 49.
51, 49. Okay.
52.
51.5, ma'am.
51.5. Again, 103 numbers are there. How are you coming with the 0.5 answers?
51, ma'am.
51. Okay. Fine. See, there are 103 data points. So
There are
obviously,
102 data points. That's the first
see,
confusion.
There is one more 50 at the last.
There's 50 as well.
yes,
Yes.
I have boxed it. See,
Okay.
1, 2, 3 till 50.
Okay.
Fine. So again, yeah, we have 5 minutes, so you can take again 1 more minute.
Then it's the 52th observation which will be 50. 50. Still
52th
answers 50.
observation will be 49.
50.
Okay.
I'm 50.
Ma'am, 49. 49, ma'am.
Yes, ma'am, 50.
50.5.
76.
Okay. Fine. So what if this question comes in your interview?
Confusion.
Sure. Oh, you are practicing now, no? So you will not get stuck there. That's why we are doing any course or like that, right? Okay, fine. 103 numbers, that means 50-second observation is your median, right?
Yes.
You were
Yes, ma'am.
struggling with the 50-second to find 50-second observation.
Yes, ma'am.
So your numbers were like 1, 1, 1 till 50. Then again one more 50. There 49 is also there. Yeah, sequence wise until 100. So these are your 103 number. So just 102 divided by 2, that means 51 observation, and 52nd observation is your median. So 1 to 50, how many numbers are these? Are 50, right? 51, 52. That means your 52nd observation is which one?
50.
Just a minute. If it is 50, then just tell me, uh, whatever your number is, the left hand side will have some 51 numbers and the right hand will also have 51 numbers, right? 51 observations. 51, 51, and the middle one is 52nd, isn't it?
Yes.
Yes, ma'am.
What
Yes,
should be the
ma'am.
answer? Again, half minute. Just take.
Sorry, ma'am, I don't get you.
See, whatever your 52nd observation is your median. Okay. Then
Yes, ma'am.
one idea was to just calculate the numbers from like that. I have given 1 to 50, it is 50 observation, and then this two, like that, right? Another method is you have to check whatever your number is, uh, left on the left there should be 51 observation, on the right also there should be 51 observation. That's what median says. Median is the measure that divides your data into two equal parts, right?
Yes, ma'am.
In further part, you will say it as a 50 percentile also.
Ma'am, 50 is the 52nd observation.
Yeah, 50 is the 52nd observation. Yeah, correct. Fine. So this was correct. Fine. Your median is 50. Was it interesting question?
Yes, ma'am, it is.
So interesting.
Okay, fine. So just you can change the sum numbers and play with the median and mode. Even the simplest thing, median and mode, can also be uh, tricky like that. Okay, so just be careful for that. Okay, is there any doubt, or like it's 10 almost, so we can stop here. Okay, then see you soon.
I
Yeah.
actually missed that whole explanation that you gave why that suggestions is not a variable or if it is.
Sorry,
If
sorry.
you
Which
can just
suggestion?
give that in one line. Oh no, in the right in the beginning. I think someone asked you that question.
Okay.
Like if we have a structured data and one of the columns had suggestions and then that thing was unstructured. So uh, something like that. I
So
just
what
had to do something.
they were asking some, even I don't remember. He or she was asking about some frequency or what?
No, no, no.
Ah,
It
no,
was right in the
yeah,
beginning.
audit ratio scale of measurement they were talking about
No,
some comments.
yes, comments.
Comments or
Yes,
some paragraph.
yes,
See, whenever there is a unstructured data, can you distinguish between the categorical and numerical?
yes,
The first step is categorical or numerical. So you will say, what will you say? Will it be a categorical even? It's not numerical, that's
no,
sure. But
yeah,
is it a categorical?
no,
Why? Because even though when we say categorical, in categorical we have one scale of measurement called as nominal, in which we
mm,
say the data which is for namesake only. But still, there is something that should be a common, that should be a meaningful, right?
yeah,
That is what the data should be structured. And one thing is, whatever your data is, it should categorize the thing, right?
yes.
But whenever the things like comments or paragraph are there, these are unstructured data. So these do not have any classification thereon. So no
So
sense of
if
scale of
so,
measurement.
even if these are within like a structured data, like we have an Excel sheet and the last column we write comments, we will not consider that comments as a variable.
Yeah,
Yeah,
like it's kind of variable in which that stored data is unstructured. We will see like that.
but no, but because I think the question was tell us the number of categorical variables, so we don't count that.
Yeah, you will
Right?
not count. Yeah.
But if the question was just what is the total number of variables, then under that we will count that comments.
Uh, in that also, I don't think so. It should be count. If the question is like to count the number of variables, then we should not count it because it's unstructured data. So no cases, no variable. Like that.
No, within a table, like
Yeah,
we
I
have
mean within a table also, we can't like
considered that.
even yeah.
Okay.
Okay. So because that person has not given me the context like this, that you were like about to calculate the variable.
Oh, it was a question, I think, in one of the
Okay, okay.
practice sessions or some assignments or some
But
practice.
as in like mathematics, if we go like that, word to word, then variable means the value which changes. So
Hmm.
according to that, if number of variables the question is, then it should be counted. Uh, or
Yeah,
but
because the comments will
yeah,
change for
yeah,
every case.
yeah. But when you ask for the categorical variable, then obviously it's not a categorical variable.
Okay.
Okay.
So variable it is, but then categorical variable it is not.
Yeah.
Right?
Yeah. Still, we can confirm it and we can have discussion over it. No problem.
Okay.
Fine.
Okay.
Okay. Okay. Thanks to all. We'll meet you soon.
For today's class. Okay, ma'am.